Good morning to all of you. So myself am Soundararajan, Assistant Professor from Department of Agricultural Engineering at Sri Shanmugha College of Engineering and Technology. So our subject is soil mechanics. As a part of our subjects, today we're going to see introduction of soil physics. This is the important topic from Unit 1 of soil mechanics. So first of all, we going to the topic. We have to know the what is the soil. So in next slide, I giving the definitions for soil. So soil is the natural unconsolidated material that lies above the bedrock and supports the plant and structural life. So it is a three-phase system consisting of solid particle, liquid and gas. So in engineering terms, soil is a natural aggregate of mineral grains that can be separated by mechanical means such as agitation in water. So it is formed by the weathering of rocks and decomposition of organic matter over time. So soil serves as a foundation material for buildings, roads and other civil structures. So it provides mechanical support and nutrient medium for plant growth. Its a physical, chemical and biological properties vary with parent material, climate and topography. The wide ratio, density and permeability determines its engineering behavior of soil. So in agricultural engineering, soil acts as a reservoir for water and nutrients essential for crops. Thus, soil is both natural resource and constructional material vital to agricultural engineering alike. So this is the so we know that what is the soil. So here I giving the some definitions for soil. So in next slide we go. So in this slide you can see the major components soil. So for your easy understanding, I gave the some pictorial representation of soil components. So soil is composed of four main components that are mineral matter, organic matter, water and air. So mineral matter forms about 45% of soil and consists of particles derived from weathered rocks such as sand, silt and clay. So sand particles are coarse and improve soil aeration and drainage. Silt particles are medium sized and help retain moisture and nutrients. Clay particles are fine and control the soil's plasticity, strength and water holding capacity. So next important component of soil is organic matter, which is contributes to the soils around 5%. So comes from decomposed plant and animal residues, improving fertility and structure. So next component of the soil is soil water, which is about 25% to the volume of soil. So occupies part of pore space and is essential for nutrient transport and plant growth. Soil air fills remaining pore spaces, providing oxygen for roots and microorganisms. So the ratio of these components determines the texture, porosity and permeability of soil. So a balanced composition of mineral, organic and water, soil and phases ensures optimum soil health and engineering stability. So the major components plays vital role for soil optimum health and then engineering stability. So in next slide, we're going to see soil forming minerals. So soil forming minerals are the inorganic constituents derived from the weathering of parent rocks. These minerals provide essential nutrients and influence the texture, color and fertility of the soil. The primary minerals are those inherited directly from rocks such as quartz, feldspar, mica. So quartz is the technically we are calling it as the SiO2 in chemical form, is resistant to weathering and contributes to the sandy fraction of soil. Feldspar, otherwise we can call it as the orthoclase or plagioclase, whether to form clay minerals and release the nutrients like potassium and calcium. So mica, which is a well-known mineral by peoples, so it decomposes slowly and enriching the soil with potassium and magnesium. So secondary minerals are such as kaolinite, montmorillonite and illite are formed by the chemical weathering of primary minerals. So these clay minerals control soil plasticity, cation exchange capacity and water retention. So iron and aluminum oxides impact on red and yellow colors to the soil and influence the soil acidity. The type and proportion of soil forming minerals determine the engineering behavior and fertility potential of the soil. So here I given the some examples of soil. What are the constituents of that soil? So for here you can see the red soil. It's a constitute of quartz, illite, muscovite, saponite, sauconite, and carbonate fluoropatate. So likewise, you can see the all examples for your reference. So in next slide, we're going to see soil forming process. So based on the weathering process, there is classified three types weathering: so mechanical, chemical, and biological weathering. So first of all, we should know about the what is the weathering. The soil forming process or pedagogenesis is the transformation of parent rock into soil through physical, chemical, and biological actions. So it involves weathering of rocks, addition of organic matter, and development of soil erosions over time. So physical weathering means breaks rocks into smaller fragments through temperature changes and freezing, thawing, wind, and water actions. So chemical weathering means it alters the mineral composition of rocks by processes like hydration, oxidation, carbonation, and hydrolysis. Biological weathering means occurs due to the activity of plants, microorganisms, and animals which decompose organic matter and enhance soil structure. See, addition means already I told you that addition means addition of organic material, some particles, some physical and chemical things to the soil gives the another format to that soil. So losses means the removal of soil materials due to the erosion, leaching, and harvesting crops. Here the leaching means moves the dissolved materials downwards and enriching the lower layer and forming the distinct soil erosions. So the next one is the transformations, means the modification of soil constituents through the chemical and biological changes such as decomposition and mineral formation. So translocation means the relocation of the soil materials to one place to another place. Due to that, the soils make another formations. So humidification, one of the important thing that converts the decomposed organic matter into humus, improving fertility and water holding capacity of the soil. So another one important process of soil forming process is eluviation or elevation, refer to the deposition and removal of mineral within the soil layer shaping the soil profile. So factors like climate, parent material, topography, organisms, and time control the rate and nature of the soil formation. The combined effect of these processes results in development of mature soil profile suitable for plant growth and for engineering uses. So here the picture clearly represents the how soil is changed over a time period. So first, its initial period it looks like very full of rocks. That is called rock fragments, and some things adding to that soil rocks like organic debris, grasses, and small shrubs are growing on that land. Then it takes some time. Then some plants are growing in that land that creates the another form to the soil. So plants are decomposing on that land, so it adding the organic matter to the soil, so then minerals to the soil. So and what due to that climate condition or in the precipitation, due to the precipitation, water is adding to the soil. So due to the physical, chemical, and biological actions on the soil, so the rock it gives the soil formation. So I think this is enough for today class. In next class, we're going to see the another important topic from the unit 1. Thank you.